All right, in this video we are going to work through the following problem. It says determine if the described lines are the same line, parallel lines, intersecting, or skew lines. If the lines are intersecting, then give the point of intersection. All right, so we have two lines, L1 and L2. Okay, so the first thing I'm going to do is take a look at the direction vectors to figure out if they are parallel or not. And you can see they definitely are not parallel to each other, right? If you look at this middle coordinate, right, if they're parallel to each other, they're going to be scalar multiples of each other. So I should be able to scalar multiply one vector to get this other vector, but you can see that's not going to work, right? Because whatever I scalar multiply by these, you can see that these two second coordinates are 1, right? And so that means that there's no scalar multiply I can multiply 5 by to get 3, right? Because that's not 1, and that would, that would change the 1 here, right? The scalar would have to be a 1, right? Because 1 times 1 is the only thing that's going to give me 1, but 5 times 1 doesn't give me 3. So that means these things are not parallel to each other, right? So that means that we're, in this case, either they're intersecting or skew. Okay. All right, so what we're going to do is use some algebra to figure that out. All right, and so what I'm going to do is to write the parametric equations. It's a little bit easier to do that. Let me try to save some room here. Okay, so the first one is going to be 2 plus 5t. Or x equals 2 plus 5t. Y equals 1 plus t. And z equals 1 minus 2t. And for the other one, we're going to do the same thing. When you're doing this technique that I'm about to show you, though, you can't have both the parameters for lines be t, because when you do that in algebra, right, then you're asserting, that those quantities are equal to each other, which they might not be. And so what you need to do is just use some other letter besides t here. Okay, so I'm going to use s, and that seems pretty common that people use s here. Negative 2 plus 3s. Y would be equal to negative 1 plus 1s. And z would be equal to 2 minus s right here. So just pretending like this is an s for the time being. Okay? All right, and so then to find where these things are going to intersect, right? If wherever they intersect, the x coordinates, that point, the x coordinates would have to be equal to each other, the y coordinates would have to be equal to each other, and the z coordinates would have to be equal to each other, right? And so what that means is that you get 3 equations here. 2 plus 5t, that would have to be equal to negative 2 plus 3s. 1 plus t would have to be equal to negative 1 plus s. 1 minus 2t would have to be equal to 2 minus s. Okay. All right, and so now what I need to do is to solve this system of linear equations. Okay. And it's a system with 3 equations, right? And 2 variables in there. So what I'm going to do is to pick one of these equations and solve for t or for s. And it doesn't really matter which one you do. This one in the middle looks pretty easy, right, to solve for t, so that's what I'm going to do. I'm going to pull that equation out and solve for t. So if I subtract 1 from both sides, I get t equals minus 2 plus s, like so. All right, so I've solved for t, right, into this middle equation. So now what you want to do then is to go to each of these other two equations. And so this is the one, I've already used this one here, this middle one, right here. I've already used that one. So I'm going to go to this other equation over here and substitute in -2 plus s for t into this one. And I'm going to go to the other one I didn't use and do that as well. Substitute -2 plus s in for t. All right, so on the first one, right, I have 2 plus 5t. And so for t, I'm going to plug in -2 plus s. All right, and then that's equal to -2 plus 3s. And I'm going to clean that up a little bit. So that's going to be 2 plus -10 plus 5s equals -2 plus 3s. So I get -8 plus 5s equals -2 plus 3s. And here I can keep solving. So I am going to subtract 3s from both sides. I'm going to add 8 to both sides. So I get 2s equals 6. Right, so s equals 3. All right, so that helps me figure out what s is, right? And then I can figure out what t is, right, by plugging s back into here. So all right, so I get s equal, or t equals 1, okay? So now what I need to do, right, to find that intersection point is to plug those values back into these equations right here, all right? And you're gonna need to plug them into both here. So plug the 1 in for this first equation and then plug the 3 in for this next equation over here and verify that they work, okay? All right, so when we go to the first line, right, we have x equals 2 plus 5 times 1. We have y equals 1 plus 1. We have z equals 1 minus 2 times 1. So I'm plugging the t equals 1 back into this equation right here, and I get a 7 for x, I get a 2 for y, and I get a -1 for z. I need to also do that, right, into this equation as well, just to check, right, to make sure that I am getting the same point back. So when I do that, I get -2 plus 3 times 3. I get y equals -1 plus 3. And I get z equals 2 minus 3 when I do that. And so just checking, here I have 9 minus 2, and that's going to be 7, so that one's working. I have 3 minus 1, so that's 2, and I have 2 minus 1, which is -3. Okay, so you can see those worked for each of those two lines right here. All right, and so so the answer, right, the intersection point here is that these, or the thing is that these lines are intersect. At exactly 1 point. And that point of intersection is 7 to -1. So make sure that you go ahead and go through all of plugging these parameters in when you do that into both of these lines. If you noticed, right, we really only used these two equations right here, right? We solved the middle one for t, right, and then we plugged back into this first one, right, to get these two parameters out, and that we got values of the parameters. So we know, assuming you did everything perfectly up to that point, you would know that those that s equals 3 and t equals 1 is the solution for these first two equations right here. But if you notice, we never used this equation right here, right, this third one. Well, that value for s and t also need to satisfy this equation as well, right? So sometimes you will get solutions that work for the first two, but not the third one, right? So you have to be careful about that. You'll see in the subsequent example videos where we'll have a situation like that, okay? So make sure you go back and check, both of these equations. All right, and that is it on this one.